And as we finish out the section 6.2 problems, we get the same instructions for problems 17 and 18 that we had for the two prior to it. So basically simplify as much as possible, and if you can't simplify, say why. So for 17, I have 2 times the 4th root of 25 times the 4th root of 75. Now, when you've got the same index, the 4th root and the 4th root, and we are multiplying, we are able to multiply our numbers under the radical. So I have 2 times the 4th root of 25 times 75 is 1,875, which good chance I'm going to be able to break something out of jail. So I make my factor chart. I've got 1 and 1875, and then I know that I'm going to have 3 and 625. So that's good news for me, since 625 is 5 to the 4th power. Remember, we're taking the 4th root, so we're looking for perfect quartic values. So then I call this guy, 2 times the 4th root of 3 times the 4th root of 625. 4th root of 625 we just said was 5, so we bring it out front, and it's going to be attached to that 2 by multiplication. 5 times 2 times the 4th root of 3, 10 times the 4th root of 3. For problem number 18, we're given a couple different radicals, so we're going to have to break each one of those down. So if we start with the square root of 54, now if you're not sure off the top of your head what it would break down into, or what your perfect factors would be, please go through and make that factor chart. But I know that we're going to be able to break 9 out. So we've got the square root of 54 just by itself. We can call the square root of 9 times the square root of 6. The square root of 9 is 3, but let's not forget we had a 3 out in front of it as well. So 3 times 3 radical 6 is going to be 9 radical 6. And then we're looking at the square root of 24. 24, again, we're going to be able to break our 2 out of jail, so we're going to be left with a radical 6 again. So radical 4 times radical 6 is what it breaks into, which is 2 radical 6, but let's not forget we also had this negative 2 out in front of it. So negative 2 times 2 radical 6, negative 4 radical 6. Notice we already have like radicals we're going to be able to combine. Lastly, square root of 63, we're going to break into the square root of 9 times the square root of 7. Square root of 9 is 3, so 3 radical 7, but don't forget about that 4 that we had in front of it. 4 times 3, we get 12 radical 7. This guy is not a like radical with the other ones, so we won't be able to combine all 3 of these, but we will at least be able to combine those first 2. 9 root 6 minus 4 root 6 is going to give us 5 radical 6 plus 12 root 7. Final answer. Now for numbers 19 to 21, we are performing root simplification again, but these involve variables. So we break them into pieces, or individual pieces, right? So we've got the square root of 9, the square root of x to the 10th, the square root of y to the 6th, and the square root of z squared. So square root of 9 is a perfect, or 9 is a perfect square, so the square root of 9 is a whole number. It's just 3. And then the square root of x to the 10th. Now, if you'd like to switch that over to fractional exponent form, be my guest. You'd have x to the 10 halves. Remember, the index value of a square root is 2, and that simplifies down to x to the 5th power. Same idea with y to the 6th. Square root of y to the 6th, you can call y to the 6 halves if you want. Either way, you get y cubed. And lastly, square root of z squared, z to the 2 over 2, which is 1, z to the 1st. And notice that everything is broken out of jail, so our final answer is 3, x to the 5th, y to the 3rd, z. Number 20, we again break this down. So I've got the cubed root of 81, I've got the cubed root of a to the 9th, and I've got the cubed root of b to the 8th. Cubed root of 81, that is almost perfect. Cubed root of 81 we call the cubed root of 3 times the cubed root of 27. We would make our factor chart if we're not quite sure. Our cubed root of 27 is just 3, so I have 3 times the cubed root of 3. Then the cubed root of a to the 9th. Fractional exponent form tells us we have a to the 9/3. Well, 9 divided by 3 is just 3. A to the 3rd power. Lastly, cubed root of b to the 8th. Now there's a couple different ways that you can think about this, and you can split it up whatever or however is easiest for you. So if we have the cubed root of b to the 6th, I know I'm going to be able to break that down because my index is a factor of that exponent, right? Kind of like we were able to break a to the 9th out of the cubed root jail because 3 goes into 9. Well, this time around, 3 goes into 6, and then I have to think about my leftovers. I originally had 8 b's under the radical, so I need to keep 8 b's, so then I'm left with 2 more. Cubed root of b to the 6th, well, that's b to the 6/3, which is just b squared. So I've got b squared, and then the cubed root of b squared left. Everything outside of the radical gets combined along with everything inside. So we've got 3a cubed and b squared all outside of the radical times the cubed root of 3b squared. Lastly, number 21, 4th root of 80 times the 4th root of a cubed times the 4th root of b to the 6th root. The 4th root of 80, we are going to be able to break 16 down out of jail. So the 4th root of 16 times the 4th root of 5. Again, if you're not sure, make that factor chart. 4th root of 16 is 2. So we have 2 times the quartic root of 5. And then the 4th root of a to the 3rd, we are not going to be able to break anything out of jail. I need 4 a's if I want to break any of them out. I only have 3. So I just have the 4th root of a cubed. That doesn't simplify further. 4th root of b to the 16th. b to the 16/4 would be b to the 4th outside of jail. Combine everything outside of jail and everything left in it. I've got 2b to the 4th times the 4th root of 5a cubed.